Hi everyone! I've been thinking about our last conversation about how sound can be reflected, diffused, or absorbed. In particular, I'm interested in exploring a little bit more about sound reflection. Understanding the properties of sound reflection can help us in ways that might surprise you, such as in navigating a ship or seeing inside the body. Before we talk about that, let's reinforce our understanding of sound reflection with an experiment. For this, you will want to set up at a table with a partner. You will also need 2 paper towel rolls, a pie pan, and masking tape. Place your tubes on the table, angled toward one another, but not touching. Secure them to the table with your masking tape. Then, set the pie pan behind them and secure it as well. It might be helpful to place something behind the pan to prop it up. Once you are ready, it should look like this. Now, ask your partner to place their ear against the opening of one of the cardboard tubes. Whispering, count to 5. Then, place your mouth against the opening of the other cardboard tube and whispering, count to 5 again. Ask your partner to note any changes in the sound. Try this a few more times and then switch places. Now, listen carefully as they whisper and write down any changes that you hear. How did it go? Did you notice a difference? Let's try it here. I have a device set up to capture the sound. I'm going to recite the alphabet both in and outside of the tube. Let's see what happens. Are you ready? Here we go. Were you able to hear a difference? Why was my voice louder when I spoke through the tube? It's because when I was speaking through the tube, the sound waves from my voice were directed through the tube, reflected against the pie pan, and directed back through the other tube. When I spoke outside of the tube, the sound waves from my voice were dispersed throughout the room, and so did not sound as loud as when I was speaking through the tube. There are some animals that are masters of understanding and interpreting sound reflection. I'm thinking of one right now. See if you can guess it. This is a small mammal. It has wings, eats insects, sleeps upside down, and is mostly seen at night. Do you know which animal I'm thinking of? Yes, it's a bat. Despite the saying, blind as a bat, they're in fact not blind. However, they do rely on a keen sense of hearing, which helps them with navigation. This process is called echolocation. Can you say that with me? Echolocation. Bats make extremely high-pitched sounds, many of which are outside the range of human hearing. When the sound reflects back, they're able to interpret this information to determine what else is in the environment, including the direction and distance of other moving objects, such as insects they may be hunting. There are other animals, such as whales, dolphins, and some birds, that use echolocation for navigation or to find food. Amazingly, some humans have developed this ability as well, including Ben Underwood, Daniel Kish, and others. One thing humans have figured out is how to use the principle behind echolocation for navigating ships. This is called Sonar, which stands for Sound Navigation and Ranging. Sonar uses sound waves to measure the distance, direction, and speed of underwater objects. The transmitter produces and transmits infrasonic or ultrasonic waves which travel through the water. When the sound waves strike an object, they are reflected back and sensed by a detector. This is very helpful when traveling by boat or submarine, since it is difficult to see the depth of the water or what might be beneath the surface. Might we be able to use this same principle to generate an image? What do you think? Have you ever heard of ultrasound scanning? This is a tool used by the healthcare industry that produces pictures of the inside of the body using sound waves. It's often used to check on the development of a baby before it is born. Ultrasound imaging uses a small probe called a transducer and a gel placed directly on the skin. High-frequency sound waves are sent from the probe through the gel into the body, and the sound waves that reflect back are sent from the probe to a computer, which then uses those sound waves to generate an image. As you can see, there are many applications for sound reflection that are used daily by humans as well as animals. Here's a DIY project you can try on your own along with a friend or two. Stand in the middle of a room with your eyes blindfolded and ask your friends to position themselves around the room. Then, ask your friends to take turns making clicking sounds. As you listen to the sounds, point in the direction where each sound is coming from. Later, your friends can let you know how accurate you were. Keep going until each person has a turn in the middle. Thank you for joining me today and learning about echolocation, sonar, and ultrasound. I'm Miss Liz from the Cincinnati Symphony Orchestra Sound Discoveries program. See you soon!